All right, gang. David Shapiro here with round two on the planning ChatGPT killer architecture. Let's pivot. So, as a quick recap, we talked extensively about the IT infrastructure, and so basically we ended up focusing pretty much on Azure Search and Azure Cosmos DB in order to save the conversations. So now let's pivot and focus on the AI itself, the language model. Um, are you familiar with LLM technology? So let's see how much ChatGPT understands about large language models. Okay, cool. So another thing that happens is when you have a conversation, an opening conversation about something, you kind of prime the topic. And this works for humans too. It also works for machines. So when you talk about a thing, you're recalling more and more facts and memories about it into memory. So this is called working memory or task set. Okay, so they're trained on large data sets. Cool. Um, can uh, can you list some LLMs you are aware of? And so what we're doing here is we're spooling up data. So we're basically creating a new task set. Okay, so it knows about GPT, it knows about BERT, um, Transformer XL, XLNet. Okay, so but it's not mentioning like GPTJ, GPT-3. Yep. All right, cool. Cool, thanks. We are using GPT as the AI backend for our chatbot. Also, I hope you don't hear the typing. If you do, I apologize. I'm using NVIDIA Broadcast to help filter out background noise. Okay, we're using ChatGPT as the backend for our chatbot. Um, let's talk about fine tuning data, prompt windows, um, and semantic. No, we already talked about search. So yeah, let's just um, basically, I need to understand how to structure um, the input and output for this chatbot. Thoughts? All right, so let's see what ChatGPT says about structuring it like this. It's important to carefully structure the input and output to ensure the model is able to learn the patterns and structures of the task effectively. Input data when training a chatbot, it should consist of a series of conversations and dialogues. Yep. Output data, prompt window when fine tuning LLM. Use a prompt window, fixed size window of text, tokenization, etc., etc. Okay, thanks. So again, we're kind of spooling up the task set, and once we ask enough questions, kind of the answers that we need should just kind of emerge. This is how problem solving conversations happen. Okay, thanks. Um, can you suggest a prompt for a chatbot? Um, are you familiar with prompt engineering? What should I populate this prompt with? All right, so it knows what a prompt is. It knows what prompt engineering is. I'm not blowing up your eardrums. Okay, cool. It looks like the dBs are pretty high, but not too far up there. Okay, content, structure, length. Okay. Thanks. But can you just write a prompt? I will test it and see if it works. Okay. So I was able to cajole it into writing me a prompt. Cool. Now let's think about how to inject um, older bits of a conversation into the prompt. When building a chatbot, you may want to incorporate older bits of a conversation into the prompt to provide context. Use a sliding window. Aha. There you go. Use a fixed size buffer to store a fixed number of previous turns in the conversation. Use a database or data store. Okay. Um, and as far as I know, people think that that ChatGPT uses a sliding window with a scratch pad. Okay, cool. Let's talk about the concept of a scratch pad or sidecar. Are you familiar with this concept? Okay. Used to store or retrieve relevant information. The idea behind a scratch pad is to allow the chatbot to maintain long term memory of the conversation and use this memory to generate more relevant, context aware responses. There you go. There are several ways that it can be implemented. Okay, great. Can you give some very specific technical suggestions about how to implement long term? No, I don't want to say long term memory because then we're going to get back into Azure Cosmos DB and stuff. Scratchpad, like what sort of prompts? How should I handle the data? That sort of thing. Um, and most importantly, how do I include info from the Scratchpad into the chat convo? Certainly, here are a few technical suggestions for implementing a scratchpad. Oh, also, if you're wondering why I'm talking quieter, it's because I'm getting used to this microphone, and I realize I don't have to project as much. It is a much more sensitive microphone. Um, so yeah. Also, I get super upregulated when I talk loud and fast all the time. So I'm trying to just stay a little bit more mellow. Okay. Use a database or data store, structure the data, use prompts, use API calls. Okay, I mean, yeah, it wanted to get back into this. Yeah. No, I mean, super specific. Um, Given a current conversation, how do I populate the the scratchpad info into Convo? Can you give some uh, prompt examples and suggestions? Like, use your imagination um, to show how this would work. Okay, here are a few examples of prompts you could use. What was the weather like on our in this? Okay, so it's basically just asking a question. I don't think it understands like how to populate the scratch pad. Or maybe I'm not asking the question right. Do a quick time check. We're only at 9 minutes. Okay. I guess I'm not. Let me slide this back just a little bit. I'm afraid I'm going to bump it. I guess I'm afraid I'm not asking correctly. List out the architectural components of the chatbot as it pertains to the chat logs and scratch pad. Then tell me how those components are linked. Um, lastly, lastly, write out a protocol or procedure um, to track the convo, um, store the logs, fetch the logs, um, populate the scratch pad, and finally fetch info from the scratch pad. Certainly, here's an outline of the architectural components. Chat logs, okay. Scratch pad, there you go. It can be implemented using a variety of approaches such as data store, database, or API. Chatbot front end, chatbot back end. Okay. User sends a message through the front end. The message is received by the back end. The back end processes the message and generates a response using the chatbot's AI models. The response is sent to the front end. Chat logs are updated with user message and the chatbot's response. Any relevant information from the conversation is stored in the scratch pad. Okay, here we go. Here we go. Please continue your last thought. I'm glad that worked. Okay, fetching the chat logs. The chat logs can be fetched from the database or data store using an API call. Populating the scratch pad. The scratch pad can be populated with relevant information. One option is to use NLP to extract the information. Another option is to use prompts or API calls. Fetching information, and I do have to I do have to concede that that I'm using a lot of my own architectural knowledge to kind of steer the conversation, but I'm at least showing that this has enough information to synthesize all of it on its own. Please continue your last thought. Oh, it said let me know. Okay. Now it's going to summarize. Got it. Got it. Okay. Um, yeah, so this actually worked better than I thought that it would. Um, it did take a little bit of figuring to get the conversation to just kind of list it all out, but it did a good job of listing the architectural components. I said, like, list the components. How do they talk to each other? Excellent. Thanks. All right. What's next? Because we understand the data and everything else. I mean, maybe that's it. Let's focus on fine tuning. You may or may not be aware, but you are a version of GPT called ChatGPT. The purpose of this exercise is to recreate you, winky face. Um, so if you look back over our conversation, this is where it's getting meta. So if you look back over our conversation, uh, you'll notice that I ask questions and you provide very thorough answers. Let's talk about the fine tuning data and or prompts required to evoke this behavior from you. There we go. In order to provide it, in order to train a chatbot to provide, why is that so hard to say? Such as the ones I've given, you will need to create a fine-tuning data set and design appropriate prompts. Here are some suggestions. Collect and annotate a large data set of conversations. Design prompts that encourage detailed responses. Use machine learning to train the chatbot. Okay, that's all fine. Cool. There's a rumor that you were trained using a GAN or something like that. Um, maybe the data set was generated by reinforcement learning with human feedback. Not sure. Let's explore those two possibilities. Can you explain how we could use a GAN or LR HF in order to synthesize or curate a fine tuning set for this chatbot project. This is where ChatGPT is telling me basically how to recreate itself. You're welcome. Okay. Using a GAN to synthesize data. A GAN is a type of machine learning that consists of two neural networks, a generator and a discriminator. The generator is trained to synthesize data that is similar to a training set, while the discriminator is trained to distinguish between the synthesized data and the real data. By training again on a large data set of conversations, you could synthesize additional conversations that are similar to the ones used in the training. These synthesized conversations can be used to create a fine-tuning data set. Using RLHF to curate data is a technique that combines reinforcement learning with human feedback to train a machine learning model. In the context of a chatbot project, you could use RLHF to curate datasets by providing human feedback to the chatbot as it generates responses to the prompts. Okay. Someone told me that RLHF was how it was done. And that they use just a bit of human feedback to tune the reward function of the RL model. Can you unpack that for me? So now we're really getting into the nitty gritty of, let's imagine that you have an open source model like NeoX or Bloom, something that you have full control over, and that you wanted to synthesize data like this. Okay, so let's see. Certainly reinforcement learning with human feedback is a technique that combines, okay, it's just telling me. One, the chatbot is presented with a prompt and generates a response. The human evaluator provides feedback on the response in the form of a reward or punishment. Okay, so that reward and punishment must be this thumbs up and thumbs down right here, okay? For example, the evaluator might provide a positive response if it is detailed and accurate, or negative if it is incomplete or incorrect. The reward or punishment is used to adjust the chatbot's internal reward function, which guides its decision-making process. The process is repeated until the chatbot learns to generate. Okay. All right. Thanks. Remember that GPT fine-tuning data is in the format of JSON-L files. So how do we take the reward punishment data and incorporate it into JSON-L files? Do you have any ideas? All right, collect the reward punishment data. Convert the data into JSON-L format. You'll need to convert it. Okay. Prompt response pair, and including the field as an additional field in the JSON object. Well, that doesn't work. Organize it into training and evaluations, blah, blah, blah. Use the JSON-L files to fine-tune the GPT model. Wait, maybe we're talking about two different things. Are you talking about the chatbot model or a second model? Like a specific reward function model? Okay. Because here's the thing. Based on what it was saying, I don't think that'll work. But if you take all that data, all the reward and punishment data, basically what you're doing is you're training a predictor. You train something that will predict whether or not a given output was good or bad. And so then the reinforcement learning model what it's trying to do is just learn this, the thumbs up or thumbs down. Okay, so collect reward punishment data, train the reward function model. Next, you'll need to train, use the reward function model to guide the training. So basically, instead of training it all in one model, you get the feedback data, and then you're predicting, will an output get a thumbs up or a thumbs down. Once you do that, you can synthesize an infinite amount of data. You also need to probably synthesize a hypothetical user, right? So you probably have a user model, the main chatbot model, and then a reinforcement learning model. Okay, I'm figuring this out as I go. Okay, cool, thanks. That's very helpful. I think we actually need 3 models. One, the main chatbot model. 2, the reward function model that predicts whether or not an output will be positive or negative. And 3, a fake user model to ask questions, basically to pretend to be me or another user. So let's think through these 3 models. Should we use LLMs for all of them, or what? And also, while this is writing, we'll do a quick time check. We're at 21 minutes. The last 11 minutes went by fast. We'll probably call this a day because this is incredibly productive. I had no idea it would get this far. And then actually we'll ask one last question because I'm satisfied with this methodology. And then we'll ask about having access to read the internet. Actually, no, we'll do that in episode 3. We'll do external data sources in episode 3, how to access the internet through or KB articles through an API. Okay, let's see what it says. It's generally a good idea to use a large language model as the main chatbot. Okay. However, you may want to consider using other types for the other 2. For the reward function, you could do supervised learning models such as a logistic regression or a neural network to predict whether a response will be positive or negative. Honestly, an LLM is going to have the best ability to predict if an output is good. Like, look at this and label it positive or negative, right? These models can be trained on labeled data. As for the fake user, you may want to consider using a rule-based or heuristic approach rather than a machine learning model. This could involve designing a set of rules or heuristics that the fake user model uses to generate prompts for the chatbot. For instance, the fake user model might be programmed to ask questions about topics that are relevant to the conversation, etc., etc. Overall, the choice is yours. Okay, we'll call it a day there because this is super insightful and very helpful. All right, well, thanks for watching and stay tuned for episode 3, where we'll talk about external sources of information.